Alright guys, let's look at the next question. The next question we do is question number 17. Question number 17 says a metal cube of side 11 centimeter is submerged in water in a cylindrical vessel with diameter 28 centimeter. Find the rise in level of water. So let's say the original level of water was still here as per the diagram that I'm making. The diameter is 28, which means the radius is given equal to 14 centimeter. At this point of time, a cube is introduced into this vessel, and when you introduce the cube, the volume of the cube will add to the volume of the water, which means the volume of water will increase in the cylinder. Let's say the new level of water is what I am marking in red here. So this increase in volume here is equal to is due to the increase in volume of the cone, no, not cone, the cube. So this is equal to the volume of cube. Correct. So this increase is nothing but increase due to volume of cube. And what shape do we have here? Yes, like I have used that word earlier, we have a mini cylinder here. Correct. The mini cylinder is here. The height of this we do not know. That's what they want us to find out. The radius of this is the same as the radius of the big cylinder, which is 14 centimeter. So we need to find the increase in height. That's the question. So increase in volume is equal to the volume of cube, which in this case is equal to L cube, which is 11 into 11 into 11 centimeter cube. Now let the increase in height, let the rise in height be h centimeter. So therefore volume of mini cylinder, if we are considering this as a mini cylinder, is equal to 11 into 11 into 11 centimeter cube, and volume is given by the formula pi r square h, which is equal to 11 into 11 into 11. Let's substitute values. So this is 22 by 7 into r, which is 14 into 14 into h, which is what we have to calculate, is equal to 11 into 11 into 11. That's 7172. Therefore h would be equal to 11 into 11 into 11 divided by 22 into 2 into 14. Let's just check. Yes, 3 elements, 11 1, 11 2. So this is equal to 11 into 11, that's 121 upon 14 into 4, that's 56 centimeter. So that's the answer, 121 upon 56. Now let's just divide. So that's 56 into 2 will give me 112. Yes, that's 112. That's 9 decimal 0. That'll give me 1. So 56. That's 10 minus 6 4. 8 minus 5 3. That's 340. That should be around 7. No, not 7. 6. So 56 into 6. That'll be 6 into 6. 36. 36. So this is equal to 2.16 centimeter. So the increase in height due to adding of a cube is 2.16 centimeter. I hope the diagram made it clear for you. The blue mark was the original volume of water. When the cube got added, the extra volume was due to the volume of the cube, which is what we said calculated as volume of cube and volume of increase of water. And then the new volume was purely because of the increase of addition of the cube, and we considered this red portion to be a mini cylinder, and we put the volume formula for volume, and then we calculated as 2.16. Let's look at the next question. The next question that we do is question number 18. It says a circular tank of diameter 2 meter is dug and earth removed is spread uniformly all around the tank to form an embankment 2 meter in width and 1.6 meter in height. So I have a diagram here. So the circular tank is of diameter 2 meter, which means this radius here is 1 meter. Let's call this radius as small r. Let's call this small r 1. So this is the radius of the tank. Next, it says embankment is 2 meter in width, which means this radius, which is our capital R, minus the small radius, which is the same as this radius here, minus small r1, is given equal to 2 meter. And the total height of the embankment is 1.6 meter. So this is the embankment which is made around the tank. The radius of the tank is r1, which is 1 meter, and the width of the embankment is 2 meter, which means r minus r1 is given as 2 meter. What do we have to calculate? We need to find the depth of the circular tank. So that's the question. So what we know for sure is volume of the embankment, because the earth removed from the tank is made into the embankment, which means volume of embankment is equal to the volume of tank, which is equal to basically the volume of earth removed. Let's calculate the volume of embankment. So let radius of tank is equal to r1, which is given equal to 1 meter, and let external radius is equal to capital R, which is not given, and width, which is equal to r minus r1, is given equal to 2 meter. That's what's given. And let height of tank be h meter. So volume of embankment, which is basically the volume of material used in a hollow cylinder, is given by the formula pi r square minus small r square into h. In this case, this is given equal to 1.6, and this is equal to volume of tank, which is given by the formula pi r1 square into h. So pi and pi gets cancelled, and we have r square minus r1 square into h is equal to r1 square into h. So r1 is not given. Let's check. So we can calculate r1 from here, which is, if small r1 is 1, which means r minus 1 is equal to 2 meter, which means capital R is given equal to 3 meter. So capital R is 3 square minus small r is 1 square multiplied with h, which is 1.6, is equal to small r, which is 1 into h. So this is 3 square, 9 minus 1 multiplied with 1.6 is equal to h. Therefore, h is equal to 8 into 1.6 meter. That's 8 and 4.8. That's 12.8 meter. So the height of the tank is 12.8 meter. So this is 12.8 meter. Therefore, height or the depth of tank is 12.8 meter. Let's look at the next question. The next question that we do is question number 20. Question number 20 says difference between outer curved surface area and inner curved surface area of a hollow cylinder is given by this much. Perfect. So let's talk about the inner radius and the external radius. So let external radius be capital R, unit is centimeter, so we'll take it as centimeter, and inner radius be small r, centimeter. So what's given is difference between outer curved surface area and inner curved surface area, and height also we need, height be h centimeter. So what's given is 2 pi capital RH minus 2 pi small rh is given equal to 352. I notice that 2 pi h is common, which means 2 pi h capital R minus small r is equal to 352. Let's substitute values, which is 2 into 22 by 7. Height is given as 28, which is given as 28 centimeter. So 2 into 22 by 7 into 28, r minus r is equal to 352. That's 7174, which means r minus r is equal to 352 divided by 2 into 22 into 4. That's 5 minus 5. Yeah, so this is divisible by 11. So that's 11 into 3 and 2. That's 11 into 2. This is 4 into 1, 4 into 8, 2 into 1, 2 into 4, 2 into 1, 2 into 2. So we get the value of capital R minus small r is equal to 2 centimeter. So I think we'll get into a simultaneous equation. This is our first equation. Let's look at the second part. Volume of the material is 704 centimeter cube. Now volume of the material is given by the formula pi r square minus small r square h, which is the volume of material used, and this is given equal to 704. Let's substitute values once again, and this is 22 by 7 into h. H is 28, and I can write r square minus r square as r plus r multiplied with r minus r. This is equal to 704. This is in the form x square minus y square, which is of the form x plus y into x minus y. This is 7 into 1, 7 into 4. So this is 22 into 4 multiplied with r plus r, and r minus r is 2 from the first equation multiplied by 2 is equal to 704. Reason, since r minus r is equal to 2 from equation 1. Let's find the value of r plus r. This would be equal to 704 divided by 22 into 4 into 2. 22, 4, 2. Yes, we've taken all elements. Again, this is divisible by 11. So that's 11 into 2. 11 into 6, 66. That's 44. So that's 4. This is 2, 1, 2, 32. 4, 1, 4, 8. 2, 1, 2, 4. Therefore, r plus r is equal to 4. And that's our second equation. So let's solve these two equations simultaneously, and we should be able to find the value of r and small r as well. And in the question they've asked us to calculate curved surface area. So r plus r is equal to 4 and r minus r is equal to 2, which means 2r is equal to 6. Therefore, r is equal to 3 centimeter. Put r is equal to 3 in equation 1, and we get small r is equal to 1 centimeter. So that's the value of small r. As per the question, they want the external curved surface area, which means external curved surface area will be given by the formula 2 pi capital R into h. In this case, 2 into 22 by 7. Capital R is 3. Yes, capital R is 3 multiplied with h, which is 28, and this will be centimeter square. 7 into 1, 7 into 4. So this is 2 into 3, 6. 6 into 4, 24. So that's 22 into 24 centimeter square. 24 into 22, that's 8 and 4. That's 8 and 4. This is 8. 4 plus 8 plus 4, 2. That's 528. So external curved surface area is 528 centimeter square. Good. Interesting question. Required us to first calculate r minus r, then we calculated r plus r, then we solved both these two equations simultaneously, and then eventually there was a tail question where they wanted us to calculate the external curved surface area. Thank you so much. That finishes this video for me. Before I leave, let me mark some homework questions for you. In fact, I haven't marked any homework questions for you from this chapter at all. So question number 8. question number 14, question number 16, question number 19. These are the homework questions I can mark for you. There are some deletions from this exercise. For example, question number 12 kind of a question never asked in a board exam. Question number 13. Question number 14 part 2, where you talk about 10% increase or 10% reduction. Those kind of questions never asked in a board exam. So these are some deletions from this exercise, and the homework questions are 8, 14, 16 and 19. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.